So today we're going to look at the polar coordinate system. You are used to graphing in the rectangular coordinate system, which is our Cartesian coordinate plane, or the XY coordinate system. That's all different names for the same thing. But it's not the only coordinate system out there. It's not the only way to plot points and curves and lines and whatnot. So this says, up until now, you have graphed on a rectangular plane containing X and Y axis. We will now look at another system called the polar coordinate system. So let's just look at the difference between these two real quick. This is what you're used to. This is what a polar coordinate grid looks like for the most part. It has extra axes in here. So we have X and Y axis. If I basically put the X and Y axis on here, it would look like this. But your polar coordinate system actually only has one axis, and it's just a ray that's like the positive part of the x-axis. So that's really the only axis that's there. Sometimes the other ones are there just to kind of help you keep up with points, but really I just kind of superimposed it on here. These 2 points are in the exact same position, but there's 2 different ways to get there depending on which coordinate system you're in. So we can convert from one coordinate system to another and get all our points in the same spot. One's easier to use than the other depending on what information that you have. You wouldn't necessarily want to be graphing them in both. Okay, but we'll graph a couple things in both just so you see the difference. All right, so what we have right here, this looks like an angle that's drawn, which it is, but this axis right here, that's what this is. This is your polar axis. So there's this point that's like at the origin. It's called the pole, or it's called the origin, and then this ray is the polar axis. So it says, to form a polar coordinate system, we fix a point O called the pole or the origin. And from O, we construct an initial ray called the polar axis. Oh, not the polar axis, the polar axis. So then we have this point P, right? We wouldn't really be graphing the whole segment right there, just the point. The segment's just showing you how far it is. So each point P, so here's our point P, we have polar coordinates. It's r theta instead of xy. R being like the radius. It's the distance the point is from the origin or from the pole, and then theta is the angle. So r is the directed distance from O to P, okay, so it's like the radius. And then theta is the counterclockwise directed angle. It's what you're graphing, formed by the polar axis and OP. But OP should have a ray above it because it is a ray. So instead of having an x coordinate and a y coordinate, you have a distance you go out from the pole, and then you have an angle that you rotate. When r is negative, we graph the point positive r, comma, theta plus pi. And I'll show you how we'll handle that once we get down to the graphing part of it. Everybody good so far? All right, so let's look at the difference between these two. So we have this point, and the ordered pair here, that 0, 3, that is your xy. So from the origin, we don't go left or right any, but we go up 3. That's where we get that point from. This point 3, comma, pi halves, that's r theta. So I go out to 3, and then I rotate around pi halves, and that's where that point comes from. So again, they're in the exact same position. It's just a different way of getting there. Okay, it's like 2 different routes to get from here to your house. Okay, you're still going to the same place. So let's look at another point. Let's look at 2, 2. Okay, so we're going to plot the point 2, 2, which is right here, so that we know that means we go to the right 2, and then we go up 2. If we were to connect those to get the hypotenuse, or like the radius there, then tell me, what would this angle measure right here be? .45, and in radians that is pi fourths. Okay, so this angle is pi fourths. And because it's 45, because it's an isosceles right triangle, if this is 2, this is 2, this is 2 square roots of 2. Okay, so another way to get to that exact same point would be on the polar coordinate system. We'd have 2 square root of 2, comma, pi fourths. Which means you go out to 2 square roots of 2, which is somewhere between 2 and 3 here, and rotate around pi fourths, and then these 2 points would be in the exact same position. For this particular point, I would say that this would be a better coordinate grid to graph it on because I can get more exact at 2, 2. Here I had to estimate where 2 square roots of 2 was, right? You're not always going to get to decide, but you'll just naturally, there's certain things that work better in polar than they do in others, and that'll kind of make more sense once we get into it. Okay, we good? Just a different way of getting to the places we've been getting to all along. All right, so let's plot some points here. So we have concentric circles. That means they all have the same center, and here's our polar axis. We're going to plot this point right here, which is 2, 7, pi 6. So from the pole, we go out to 2, and then we rotate around to 7 pi 6, and we'd end up right there. That's point A. Any questions about that? All right, so I want you to do B. Plot point B. So to do B, I'd go out to 0.5, rotate around to 3 pi fourths, and I would end up right there. Agree with that? You should be able to find where pi fourths is on your circle just fine. Okay. So now let's look at point C. We have 3 negative pi thirds. So I go to 3. I have a negative angle, so I go clockwise pi thirds and end up right here. That's where C would be. Any questions about any of those at this point? All right. So now we have one with a negative radius. Remember, we wrote something up there about the negative radius. If I have a negative radius, then I plot the point with a positive radius, and then my angle is pi plus pi fourths. Okay, so let's talk about what that means and how to get there, and then what we can really do to kind of simplify things. So I'm going to go to a positive 1, because there is no negative 1. I'm going to go to a positive 1. I'm going to rotate to pi fourths, which is right here, but then I need to go another pi. Pi is how much of the circle? Half. So if I'm going to go halfway around, I'm basically going to still be on the diameter. So if I'm currently at a pi fourths angle, I'm going to end up at a pi fourths angle on the other side of the diameter, which means I'm in the third quadrant, right? So my third quadrant pi fourths angle is 5 pi fourths, and I would end up right here. Now we can really get there a whole lot easier without all that thinking, okay? Because since it is on the diameter, I can just pass right through the pole. So when you have a negative radius, I go to 1, rotate to whatever the angle is, pi fourths, but I don't put my point there. I pass through the pole and go 1 on the other side. You can, but you really don't want to have to think about much about any of them, but that works too. Yes, you can do pi and then go to pi fourths. All right, so let's look at E. I've got 2.5, 4 pi thirds. So I'm going to go to 2.5. I'm going to go to 4 pi thirds, which is right here, and then I'm going to pass through the pole to end up over here. And that's my E. So I go to 2.5. Yeah, I know it says negative, but I go to positive 2.5, 4 pi thirds. So 2.5, 4 pi thirds. I'm right here. And then, but I don't put it here because it was negative. I have to pass through the pole, and I go 2.5 on the other side. All right. You plot F. So that's where F should be. Then I'll talk you through it. I went to 3, negative pi 6, pass through the pole, put it at 3 on the other side. What questions do you have? All right. So this says, while each pair of polar coordinates plots a unique point, each point does not have unique coordinates. In general, a point with polar coordinates, r theta, can be also represented by blank. All right, so we're going to write this out, and then I'm going to re-explain that wording, because that type of wording can be confusing, I know. So r theta, basically, there's an infinite amount of ways to get to one point, because that could go in different directions, right? So if I have a point r theta, it can also be represented by r, comma, theta plus 2 pi n, or negative r, comma, theta plus 2n plus 1 times pi, where n is an integer. So n is an element of the integers. Right? Get that written down, and then we'll talk about it. We're going to talk about it using this first one here. Okay, so we're going to plot this point 2, 5 pi thirds on this. So I'm going to go to 2, rotate around to 5 pi thirds, which is right here. So that's where that point should be. So that's not the only way to get here, right? I could go to 2 and go negative pi thirds. Would you agree with that? I could go to 2 and I could go around a few different ways, right? I could end up over here and pass through the origin. So there's an infinite amount of ways to get to that one point. That's what this means. This ordered pair is only going to plot one point. That's it. But there's an infinite amount of ordered pairs I could get from that one point. See the difference there? Okay. But so what they're asking us to do is they're asking us to name other points. We're not going to name an infinite amount of them. We're only going to go from negative 2 pi to 2 pi, which means there's 4 total points. So if we start with 1, we're going to have 3 answers. So let's talk. So we've already talked about one of them, right? One of them is that I could go to 2 and then negative pi thirds. The other 2 possibilities when you go from negative 2 pi to 2 pi is having a negative radius. So if I have a negative radius, I'm going to end up on the diameter over here. And this is one reason why I prefer to teach it when you're plotting the negatives to go through the origin instead of just doing pi plus. Even though it's fine, there's nothing wrong with it. It's because it kind of helps on this. So if I have a negative radius, then I want to land on the diameter, and I'd have to land right here. So I always plot the point, and then I'll put a little star where I need to land if I have a negative radius. So to get to here, if I have a negative 2, that would be a positive 2 pi thirds, and then my negative 2 radius would pass through the point, or through the pole. So I got 2 pi thirds. Another way to land on that star is to go a negative what? 4 pi thirds. So the total of 4 ordered pairs that you have, you'll always have 2 with a positive radius, 2 with a negative radius, 2 with positive angles, and 2 with negative angles. Okay. What questions you got? We're going to do another one of those together. And you're not always going to have a big, beautiful graph right there, but just like the other ones, you can sketch one out, and you don't have to draw the crazy circles on there necessarily. All we need is circle and the axis. Okay? Then we're going to plot this point, negative 5, negative 7 pi fourths. So my angle, starting at 0, negative 7 pi fourths ends me up in the first quadrant, and then that negative 5 pushes through, and I end up right here. So that's where my point is. I draw in the line that has the radius on it, because this is where I have to land if I end up with a negative radius, right? Because that's where I landed. I went negative 7 pi fourths, landed there, passed through the pole. So this is one negative radius. I'll have another one that has a negative radius. Another way to get here besides negative 7 pi fourths is what? pi fourths. So I can go to pi fourths, negative 5. Or negative 5 pi fourths. But then my other two answers are going to have a positive radius, which means that I'm going to go directly there. So to get directly here, my third quadrant pi fourths angle is what? 5 pi fourths. And then I could go to get directly there a negative what? 3 pi fourths. Good. What questions do you have? Yes, exactly. So you end up with all the angles, sort of, but I know what you mean with the little quotes. You're using all 4 of the possibilities, but 2 of them will be the negative version and 2 of them will be the positive version. So if you do end up with a negative 3 pi fourths and a positive 3 pi fourths, something's wrong. Because each angle only shows up once, but you have to figure out if it's positive or negative. Good observation. Anything else? Good observation. Okay, so you do number 9 on your own. I'll go ahead and plot the point just to make sure that we're all on the same page here. If you wrote them in a different order than I did, that's totally fine. But once you're done, double check yourself with me. Let me know if you have any questions. Okay, so we could all write them down in a different order because it's just whatever order makes the most sense in your brain, that's fine. However, your assignment is in Delta Math, and when you put in your 3 answers, you have to put the ordered pairs in a specific order. And it says this on there. I just want to make sure you understand what I mean, because I think that, my instructions make sense to me in my head, but then, you interpret it a different way, that's something different. So what it says is, and so my suggestion is that you write them all down. Don't try and find them in the order I'm telling you to find. I don't care what order you find them in. Write them down, but then when you enter them so that we're all consistent, it says to enter them with the theta measures from least to greatest. That doesn't mean switch your R and theta. That makes no sense. The ordered pair is what it is. But of your 3 answers, this one has the smallest theta value, right? So it's going to go in first. The next smallest theta value is this one. So this one goes in second, and then this one goes in third. Because it won't take it in whatever order. It's just the way I had to do it, okay? So on number 8, which ordered pair would we put in first? The last one. And then which one would go in next? The first one and the third one. Okay. Not that you're typing these in. I just want to make sure you understand what I mean. Number 9, which one would go in first? The first one. Then the second one. So in this case, I ended up finding them in order, but that may not have been the order you had them in. That's why we have to make sure it's specific. Okay? We good? Any questions? Why would that not work? Okay, so if I have negative 5 pi 6, negative 5 pi 6 gets me right here. then the negative 1.5, I would end up over here. But this is where I want to end up. This is where I have to land if my radius is negative, because I have to pass through the pole to put the point. So that's why I would have negative 11 pi 6 end up here, but then that negative 1.5 pushes me over here. Does that help? Okay, good. Anything else? Awesome. Don't forget you have a quiz Monday over what we did yesterday in your assignments in Delta Math.